So this is my second video, 2019 in Alum Odyssey. So my crystals have grown a lot since the first video. There are now 6 crystals in the container and they vary in size. None of them are the exact same shape and some are more clear than others. The differences in clarity of the crystals are likely due to the varying amounts of impurities that remain despite my lab partner and I's attempts to clean the product. There's much less solution in the container now as well, as you can see, which makes sense because the crystals are forming as the solution evaporates, so there's less solution because the solution's evaporating. However, crystal growth is slower than it would have been at the beginning of the experiment because I did spill some of the solution before filming my last video. And this is important because it means that there's less alum dissolved in the solution, so there's less in the container to form a crystal. The recent colder temperatures have also probably affected my crystal growth because crystals grow faster in warmer temperatures due to the solvent holding the solvent holding the crystals evaporating more rapidly in the warmer temperatures. This means that between the mix of colder weather and my roommates decreasing the thermostat temperature in my room, my crystals are probably growing at a slower rate than they initially were. However, this should theoretically grow neater crystals because there's more time for the ions to form a more perfect lattice. So here is the equations that we'd use. And so I used this in my calculation of theoretical yields for the product because I knew how much aluminum I initially started off with, so that was the initial stoichiometric constants. And so we had exactly 1 gram of solution. And then, so I used this, I had to convert to moles because the stoichiometric constants are in terms of moles. And then, yeah, so there's canceling those. And then it's the same ratio. And then I multiplied by 258.192 grams because that's how many grams are in 1 mole of the alum. And I got 9.57 grams. And so percent yield is the actual yield over the theoretical yield times 100. And this just tells you like how effective your experiment was in producing as much product as it theoretically could if everything were to go correctly. So theoretically we could have produced a max of 9.57 grams of alum due to our initial starting point. And we ended up getting 9.54 grams, which is actually really close. And so when I did this calculation, I found that we had a 99.68% yield, which is really good. We're happy about that. And so my experimental yield was not exactly 100% because the reaction may not have produced the exact stoichiometric amount of product. We also had less due to, we also could possibly have less due to inaccuracies in scraping the product out of the original container or just or something like that as well. And then the fact that the crystals are not perfectly clear suggests that there are impurities in the solution, which could be a result of impure alum. And then this impure alum could be a contributing factor to our very high experimental yield.